Hello everyone, I'm Himanshu Vasnani from Department of Mechanical Engineering. I'm here to discuss on the subject Material Science. The subject code is ME207 and unit number 4, lecture number 23, and topic name is Alloy Cast Iron Effect of Impurities on Cast Iron Wrought Iron. So let's start the lecture for today. Learning objective for today is to provide the students with a basic understanding of alloy cast iron, effect of impurities on cast iron and wrought iron. And the learning outcome for today will be the students will have learned the basics of alloy cast iron and wrought iron and student understood the effect of impurities on cast iron. So let's start the lecture for today. Ah, the various types of cast iron. Okay, now we have been discussing about the cast iron in the last lecture. Okay, the main ferrous metals available. So among them, we were discussing about the cast iron. Okay, so the various types of cast iron are like the first one is the gray cast iron. Okay, it is like an ordinary commercial iron and having the composition like the carbon from 3 to 3 the carbon from 3 to 3.5% and silicon from 1.2.75% and manganese from zero point 0.4 to 1.0%, then phosphorus from 0.15 to 1%, and then sulfur from 0.02 to 0.15%. Okay, sulfur content is 0.022 to 0.015%, the remaining is iron. So you can say that as the name says, it is a grey cast iron. So the grey color in this is due to the fact that the carbon is present in the form of free graphite. Okay, it has low tensile strength and it has high compressive strength and no ductility. These are the properties of cast iron, that it has low tensile strength and high compressive strength and no ductility. Okay, so for this it can be easily machined, and it has a good property of grey cast iron is that free graphite in its structure, it acts as a lubricant. Okay, and due to this reason it is very suitable for those parts where sliding action is required, because there the grey cast iron, the free graphite in the structure is acting as a lubricant. So the grey iron fillings, the grey iron castings are widely used for machine tool bodies, automotive cylinders, blocks, heads and housings and flywheels and pipes and pipe fittings and agricultural implements. So you can see that grey cast iron castings are having you can say tremendous applications. Okay, the gray iron castings are these are widely used in machine tool bodies and automotive cylinder vehicle blocks and heads and housings and flywheels and pipes and pipe fittings and agricultural implements. So these are numerous applications of gray cast. Then we go with the white cast iron. Okay, the white cast iron, as the name says, it shows a white structure and has the following compositions like carbon from 1.75 to 2.3% and silicon from 0.85 to 1.2% and manganese from less than 0.4% and phosphorus that's less than 0.2% and sulfur is less than 0.12% and the remaining is iron. So these are experimental data that what are compositions such white cast iron is having. So, as the name says, white cast iron, that the white color is due to the fact that it has no graphite and the whole of the carbon is in the form of carbide. Okay, it has no graphite and whole of the carbon is in the form of carbide, that is known as cementite, which is the hardest constituent of iron. Okay, now this is a very good, you can say, feature of this white cast iron. It is having no graphite and it is made all of the carbon in the form of carbide. Okay, so the white cast iron has a high tensile strength. Okay, and low compressive strength. So since it is hard, therefore it cannot be machined with ordinary cutting tools. It requires grinding as shaping process. Now the white cast iron may be produced by casting against metal chills or by regulating analysis. And the chills are used when a hard wear resisting surface is desired for such products. For car wheels and rolls for crushing grains and jaw crusher plates. So you can see these applications, okay, of white cast iron. Then we go further with the chilled cast iron. So it is a white cast iron produced by quick cooling of molten iron. The name says chilled cast iron. So it is produced by quick cooling of molten iron. So the quick cooling is generally called chilling, and the cast iron so produced is called as chilled cast iron. Okay, so all castings are chilled at their outer skin by contact of the molten iron with the cool sand in the mold. Okay, with the cool sand in the mold. But on mold castings, this hardness penetrates to a very small depth, that is less than 1 mm. Okay, because obviously the outer layer is chilled first, and then the chilling goes inside. Okay. Sometimes the casting is chilled intentionally, and sometimes chilled becomes suddenly accidentally, you can say to a considerable depth. Okay, the intentional chilling is carried out by putting inserts of iron or steel chills into the mold. I repeat once again, the intentional chilling is carried out by putting inserts of iron or steel chills into the mold. Okay, so sometimes you do it intentionally, and sometimes chilling becomes accidentally. Okay, to a considerable depth. So when the molten metal it becomes into contact, it comes into contact with the chills. Its heat is readily conducted away, and the hard surface is formed. Okay, when the molten metal it comes in contact with the chills, its heat is readily conducted away. It is taken away, and then the hard surface is formed. Now the chills are used on any faces of a casting which are required to be hard to withstand wear and friction. Now the properties that we require in chilled cast iron is to withstand wear and friction. That's why you go for a chilled cast iron products. Okay, so let's go further. Now mottled cast iron. Okay, it is a product in between the gray and white cast iron in composition, color, and renewal properties. Okay, it is in between the gray and white cast iron in composition. Okay, so the compositions you can we have studied about the of gray cast iron in the previous slides, and in the white cast iron also in the previous slides. So composition you can discuss from there also. So when you talk about mottled cast iron, so you can say that it is a product in between the gray and white cast iron in composition, color, and properties. So it is obtained in castings where certain wearing surfaces have been changed. Okay. Now, malleable cast iron. Okay. Now, the malleable iron is a cast iron carbon alloy, which solidifies in as cast conditions in a free graphite free structure. Okay. And its total carbon content is present in its form as cementite. So it is ductile and may be bent without breaking or fracturing the section. A very nice property of this malleable cast iron that it is ductile and it may be bent without breaking or fracturing the section. The tensile strength of the tensile strength of the malleable cast iron is usually higher than that of gray cast iron, okay, and has excellent machining qualities. Okay. So it is used for machine parts for which the steel forging would be too expensive. Okay, and in which the metal should have a fair degree of accuracy. That they have examples like hubs of wagon wheels and small fittings for railway stocking, railway rolling stocks, and brake supports and parts of agricultural machinery, pipe fittings, door hinges, locks. So you can see that medieval cast iron has numerous numerous applications. Okay, and it is used for machine parts for which the steel forgings would be too expensive. Okay, so you can see that how it is helping in the manufacturing industry. Okay, so let's go forward. In order to obtain a malleable cast iron, it is first cast into molds of white cast iron. Okay. Then by a suitable heat treatment, that is annealing, annealing is done to relieve the internal stresses. Okay. The combined carbon of white cast iron is separated into nodules of graphite. Okay. After the suitable treatment, that is annealing, the combined carbon of the white cast iron is separated into nodules of graphite. So for this, we have the two methods. One is the white heart process, and second is black heart process. Okay, the white heart process, and they say that in the white iron castings are packed in iron or steel boxes, surrounded by a mixture of new and used hematite ore. I repeat, in white hot process, the white iron castings are packed in iron or steel boxes, surrounded by a mixture, surrounded by a mixture of new and used hematite ore. Now the boxes are slowly heated to a temperature of 900 to 950 degrees centigrade. You can see the temperature and maintained at this temperature for several days. Okay, they are heating to the temperature of 900 to 950 degrees centigrade, and then they are maintaining this temperature for several days, it depending upon the data available. So during this period, the some of the carbon is oxidized out of the castings, and the remaining carbon is dispersed in small specks throughout the structure. Okay, the remaining carbon is dispersed in small specks throughout the structure. Now the heating process. Okay, after dispersion, we are discussing about the heating process. Then the heating process is followed by the cooling process, which takes several more days. Okay. The result of this heat treatment is a casting which is tough and will stand heat treatment without fracture. So this is how the white heart process done. Okay, and you take a white iron castings, and then you heat it to a particular temperature, and then you keep it at that temperature for some time, and then you allow it to cool it for several days to obtain this kind of a product. Okay, so the result of this heat treatment is a casting which is tough and will stand heat treatment without fracture. So very nice process. Then black heart process. So in black heart process, it is another process after white heart process. So the castings used less carbon. The used contains less carbon and sulfur. They are packed in a neutral substance like sand, and reduction of sulfur helps to accelerate the process. So the castings are heated to a temperature of 850 to 900 degrees centigrade. Okay, and maintained at that temperature for 3-4 days. So the carbon in this process transforms into globules, unlike white hard process. The casting produced by this process are more malleable. Okay, the black hard process castings they have more malleability. Okay, and the temperature if you compare of black hard process with the white hard process, the temperature is less. The heating temperature is less in case of black hard process. Okay, and the two ways I have just discussed with you. Then let's go forward. This is just a diagram, okay, showing the recovery plant, okay, like in which you can say the mixed waste is passed against a conveyor belt and sorted into reusable materials like steel, aluminium, paper, glass, okay. So the recycling plants are expensive but will contain essential as vital resources become scarce. So you have to use such kind of recycle plants because you know that creating you can say yeah, or you can say using the resources again and again will lead to their depletion. So it is better to recycle them also. Okay, so you can see the different materials like holding mixed waste on the upper side that containing steel and other paper and plastic and aluminum and glass, and then there are steel objects that are carried on a conveyor belt for processing, and then you have the electromagnet which removes iron and steel in the belt. You can see that in the on the upper side. Okay, that it is removing iron and steel, and that those are carried away on the conveyor for processing. Then the second belt conveyor is made of chains, so you can see that powerful fans that blow paper into wire receptors. So you can see that how the paper are separated. Then you can see that it is having a chain, so the glass falls through chains and is sorted by hand into three colors, that is brown, green, and clear, because normally these three colors are available for glasses. And regarding the magnetized drum, it holds the aluminium. You can see there, and this is how this plastic waste. You can see the in the last zone you have the plastic waste that is carried away for processing. This is how a recycle plant works. Just for knowledge. Okay, thank you. Now, the sixth type of cast iron is nodular or spheroidal graphite cast iron. So the nodular or spheroidal cast iron, graphite cast iron is also called as ductile cast iron and or high strength cast iron. Okay, This type of cast iron is obtained by adding small amounts of magnesium like 0.1 to 0.8% to the molten gray iron, and the additional magnesium, okay, the addition of magnesium causes the graphite to take form of small nodules or spheroids instead of normal angular flakes. So it has high fluidity. It has high fluidity, castability, tensile strength, toughness, wear resistance, pressure tightness, weldability, and machinability. See, by just addition of some magnesium in it, and you can understand that how much you can say properties does this nodal or spheroidal graphite cast iron is having. Okay, so you can understand this how it is. You can say magnesium can do wonders. Now, it is generally used for casting requiring shock and impact resistance, along with good machinability, such as hydraulic cylinders, cylinder heads, rolls for rolling mills, and centrifugally cast products. So you can see the applications, okay, of this you can say material. So, thank you. Then, according to the Indian standard specification, that is IS 1865, you can say the nodal or spheroidal graphite cast iron is designated by the alphabets SG, followed by the figures indicating the minimum tensile strength, okay, and the percentage elongation. Like for example, SG 400/15 means the spheroidal graphite cast iron with 400 MPa as minimum tensile strength and 15% elongation. This is the way they are designated. So the Indian standards recommends 9 grades of spheroidal graphite cast iron based on mechanical properties measured on separately cast test samples, and 6 grades based on chemical properties measured on cast on sample. So this all have been shown in coming table 2.4. So here in this, the letter A after the designation of the grade indicates the properties are obtained on cast on test samples, distinguish them from those obtained on separately cast test samples. So let's check the table, and so you can see this table 2.4. Okay, so it is having the grades of spheroidal graphite cast iron, and you can see that in this you have the grade SG, then you 900 oblique 2. So here it is showing that the minimum tensile strength is given 900, and then minimum percentage elongation is 2 here. So and the hardness is given like 280 to 360, and the constituent of matrix is bainite or tempered martensite. So these all materials or the structures we have studied in the iron carbon diagram like bainite and martensite and pearlite, a shining microstructure, and then tempered structure, and then again ferrite. Okay, so these all structures we have discussed in the iron carbon diagram and these microstructures. So the grades are like SG 800 oblique 2. So with various minimum tensile strength and percentage elongation, you have different grades like SG 600 oblique 3, SG 500 oblique 7, then 450 oblique 10, then you have SG 400 oblique 15. So you can see the constituent of matrix like ferrite. So ferrite is existing in most of the stuff you can say grades. You can easily see, and then perlite is also there for many of the grades. So in this way, you can see that how the hardness is you can say showing for different grades. As the you can see the percentage elongation is less, the hardness is more for that, and as such the percentage elongation is increasing. Obviously, the hardness is somehow being fluctuating according to that. So in this way, there are these grades are there for available, and these grades are available for you to learn and understand. Okay, so let's go next. Then alloy cast iron, very important topic. Alloy cast iron. So the cast iron, which contains small percentages of other constituents like silicon, manganese, sulfur, and phosphorus. Okay, these cast iron are maybe called as plain cast iron. Okay, the alloy cast iron is produced by adding alloying elements like nickel, chromium, molybdenum, copper, manganese in sufficient quantity. Nowadays we are using alloys in case of instead of using some pure materials or pure metals. So why not alloy cast iron? So alloy cast iron has its own application. Okay, so they said that alloy cast iron are like those cast irons which have some additions of some other constituents like silicon, manganese, sulfur, and phosphorus. Okay, and these elements are helping to obtain some certain properties, some certain improvements. Like the along elements may give more strength and result in improvement in the properties. Okay, then the alloy cast iron has special properties like increased strength, high wear resistance, corrosion resistance, or heat resistance. So these are some improved properties that you are desired in your workpiece. And this alloy cast iron is these elements that are added in the cast iron. These are capable of giving you such kind of properties like increased strength or high wear resistance, corrosion resistance, or heat resistance. So the alloy cast iron are extensively used for gears and automobile parts like cylinders, piston rings, crank cases, and crank shafts, cam shafts, and sprockets, and wheels, pulleys, brake drums, and shoes, and parts of crushing and grinding machinery. So you can see the properties of increased strength or high wear resistance is giving so much applications to this cast iron. Okay, the properties like corrosion resistance or heat resistance or increase and strength and then high wear resistance this has given them too much applications in the industry. This alloy cast iron. So this alloy cast iron is very used in the automobile industry for making parts of automobile. So and the parts are really important as you can see the examples. So the effect of impurities on cast iron. Okay. The cast iron it usually contains small percentage of silicon, sulfur, manganese, and phosphorus. Okay, they have an effect on the cast iron. Okay, they have an effect. So we will discuss the effects of these impurities individually. Like the first one is silicon. Now it may be present in cast iron up to 4%. So it provides the formation of free graphite, which makes the iron soft and easily machinable. Okay, we studied this in the gray cast iron. In there. So it may be present in the cast iron up to 4%, and it provides the formation of gray or free graphite, which makes the iron soft and easily machinable. It also produces sound castings free from blowholes because of high affinity for oxygen. Okay, now if you use the cast iron which has silver content, which has silicon content in it, so it will help you to produce a casting which is free from blowholes. Okay, because of its high affinity for oxygen. And let's go with the next material that is element that is sulfur. So it makes the cast iron hard and brittle. Okay, hard and brittle. So since too much sulfur gives unsound castings, so it should be kept below 0.1% for most foundries purposes. So you can see that the sulfur is making cast iron hard and brittle. Okay, and if there is too much of increment in the sulfur, then it will give you unsound casting. So very minimal amount, like 0.1% of is kept for foundry purposes. You know, because you need to have a good casting. Okay. Then the next element is manganese. Now manganese it makes the cast iron white and hard. Okay. So it is often kept below 0.75. Okay. Now it helps to exert a controlling influence over the harmful effects of sulfur. Now the harmful effect of sulfur will give you the effects are like if it is more in the cast iron, then it will give you unsound casting. So it keeps the manganese keep the controlling influence of on the sulfur. Okay, and the next element is phosphorus. So it aids fusibility and fluidity in cast iron. Okay, it aids fusibility and fluidity in cast iron, but induces brittleness. So it's rarely allowed to exceed 1% because it will give you brittleness. The phosphoric ions are useful for castings of intricate design and for many light engineering castings where cheap is essential. So if you want go for a cheap material, it should have phosphorus. Okay, it will have okay, let's go further. Now the wrought iron, one of the most important iron ferrous metal that it should be. That should be known to you. And it is the purest iron which contains at least 99.5% iron, but may contain up to 99.9% iron. So the typical composition of wrought iron is like carbon is like 0.02%, and silicon is 0.1%, 0.12%, sulfur is 0.018%, phosphorus is like 0.02%, and slag is like 0.07%. The remaining is iron. So you can see the presence of other elements is very less when compared if you compare with the other available cast iron like of white cast iron or grey cast iron. The wrought iron has very less percentage of other elements, and it has iron up to 99.5% to 99.9%. So it is one of the purest form of iron available, that is called as the wrought iron. Okay, so you can look at the diagram also how the wrought iron is looking like. So let's go to the next slide. The wrought iron is produced from pig iron by remelting it in the puddling furnace of river battery type. So the molten metal free from impurities is removed from the furnace as a pasty mass of iron and slag. So the balls of this pasty mass, each about 45 to 65 kg, are formed, and these balls are then mechanically worked both to squeeze out the slag and to form into some commercial slab. So the wrought iron is a tough, malleable, and ductile material. Okay, it cannot stand sudden or excessive shocks. So its ultimate tensile strength is around 250 MPa to 500 MPa, and the ultimate compressive strength is around 300 MPa. So you can see the tensile and the compressive strength is given. And though the this wrought iron is tough, malleable, and ductile material, okay, and sudden shocks are not you can say acceptable. Okay, it cannot stand sudden and excessive shock. So it can be easily forged or welded, and it is used for chains and crane hooks and railway couplings and water and steam pipes. Okay, so it also have its own applications. Okay, in chains or crane hooks and railway couplings and water and steam pipes. So now the steel, very important ferrous metal that is used in the commercial and in the domestic field, and very commonly known by the people and wide applications in the industry. So let's talk about it. That it is an alloy of iron and carbon with carbon content up to maximum of 1.5%. Okay, the carbon occurs in the ability to increase iron carbide because they want was because they have the ability to increase the hardness and strength of the steel. So other elements like silicon, sulfur, phosphorus, manganese are also present to greater or lesser amount to impart certain desired properties to you. We discussed about certain properties of these elements that it gave to the cast iron. So similarly, it will have the effects on steel also, but it will range. It will vary from cast iron to steel. Okay, it will vary, but it will impart some or the other. These elements will impart some or other properties. Okay, and most of the metals produced nowadays is plain carbon steel or simply carbon steel. Okay, so you can define a carbon steel as a steel which has its properties mainly due to its carbon content. Okay, due to its carbon content, it has all its properties, so it is named as carbon steel and does not contain more than 0.5% of silicon to 1.5% of manganese. Okay, so it does not contain more than this much of silicon and this much of manganese. So you can understand this is having its application, plain carbon steel. Now the plain carbon steel varying from 0.06 uh, carbon to 1.5% carbon are divided into the following types depending upon the carbon content. Now they are further this carbon steel is further classified into four different categories depending upon the percentage of carbon. Okay. Now the elements are okay. They will talk it later. the silicon, sulfur, phosphorus, and manganese. This will be talked later. But now, for now, the carbon content in carbon steels. Now they are discussing about that. Now the four categories are like dead mild steel. It is having up to 0.15% carbon. Then low carbon or mild steel that we are using in the workshop, and it is called as, it is has 0.15 to 0.45% carbon. Then you have medium carbon steel. It is having 0.45 to 0.8% carbon, and then the high carbon steel that is also using in the workshop. That is having 0.8 to 1.5% carbon. Okay, you use this high carbon steel in the workshop for that in the form of tool maybe. So it is having zero point 0.8 to 1.5% carbon, and then low carbon or medium carbon or mild steel also used as workpiece in the workshop. So according to the Indian standard, they say a new system designated the steel is recommended. Okay, so they, according to the standard, steels are classified on the basis, are designated on the basis of two bases, like on the basis of mechanical properties and on the basis of chemical composition. Okay, now they have designated the steels on these two bases. The two bases like mechanical properties and chemical compositions. So, so steels designated on the basis of mechanical properties. Now you're talking about the mechanical properties. Okay, they say that the steels are carbon. These steels are carbon and alloy and low alloy steels, where the main criterion in the selection and inspection of the steel is the tensile strength or yield strength. So, according to Indian standards, these steels are designated by a symbol Fe or FEE. It stands for iron, okay. And depending on whether the steel has been specified on the basis of minimum tensile strength or yield strength, followed by the figure indicating the minimum tensile strength or yield stress in newtons per mm square. For example, Fe290 means a steel having a minimum tensile strength of 290, and Fe 220 means a steel having a yield strength of 220. Now, where there is this is Fe and then the figure, it is having minimum tensile strength. And if you if in E in the that Fe 220, that means the steel having yield strength of 220. Okay. Now here the designations are told to you. Then the table is there which shows the yield and the tensile and the yield properties of standard steels. Okay, that are used in the industry in the common world. And that this table is as like you can see in the table how it's looks. Ah, you can see in the table the first column is of Indian standard designations like in the FE and the FEE, and then the value is given of various materials that they have the standardized. And then you have the second column is of tensile strength, in which you have the tensile strength given. Then you have the yield strength given in that, and after that the minimum percentage that you can get, and after that the usage of these materials. Like you can see there's this Fe290 or Fe220. Okay, these have the tensile strength of 290 and yield strength of individually of like 220 is the yield strength of the second material. So you can see the applications like it is used to plane down or enamel parts or tubes for oil well castings and steam water air passages. Okay, then motorcycle and automobile tubes. Okay, so you can see that the applications are vast. Then if you compare, then if you go with the other than FE310 or FE E230 or FE330 or FE E220, so it is having the you can see the application that these tubes are used for locomotive carriages and construction, screw stocks and other general purposes. So you can see that how the applications are there and how the Indian standards have segregated the steels that is having the that it should have the minimum tensile strength, the yield strength for a particular application. Like you can see there is Fe490 and Fe370. You can see the Fe490 has the tensile strength of 490 and Fe370 has the yield strength of 370. So you can see that is used for mines or for forgings for marine engines and sheet pilings and machine parts. So you can see the application. And if you go further, like Fe690 and Fe520, So Fe 690 is having the tensile strength of 690, and Fe 520 is having the 520 yield stress. So it is used for locomotives, carriages, and wagon wheels, and tires and arches for mines, to seamless oil well casings and drill tubes, and machine parts for heavy loading. So it is the usages are easily known to them. Okay, so based upon the applications also you can understand what kind of material you can use. So the steels from grades Fe290 to Fe490 are available for are general structural steels and are available in the form of bars and sections and tubes and plates and sheets and strips that you can see in the application that we have discussed just now. And the steels of grades Fe440 to and Fe620 are medium tensile structural steel, and then the steels of grade 690, Fe 770 and Fe 870 are high tensile steels. So they have just given you this table to make you have a better understanding of the designations that they are given, and then their applications. They are divided into these three categories. Okay. So, this chart or this table will give you a better overview of the steel, of the applications of steel in the industry. Now, steel designated to on the basis of chemical composition. So, they according to the Indian standards, and the carbon steels are designated in the following order. The figure indicating 100 times the average percentage of carbon content. Then the letter C is there, and the figure indicating 10 times the average percentage of manganese content. Firstly, it is the carbon content, then the letter C, and then the manganese content. The figure after multiplying will be rounded off to the nearest integer. Like, for example, they say 20 Ca. That means that a carbon steel having 0.15 to 0.25%, that is carbon, and then zero point 0.6 to 0.9%, that is 0.75 around 0.8% manganese. Okay. Now they are given this example, and again the table 2.6, which is showing the Indian standard designation of carbon steel with composition and their uses. So let's go to the table. According to the Indian standard designation, they have given that the 4C2 is the designation, and then you can see that the maximum carbon is around 0.08 maximum, and the manganese having 0.04. Okay, and it is used as it is a dead it is that soft steel generally used in electrical industry. Okay, it is a dead soft steel used in the electrical industry. Then you have the designation like 5C4 and 57C4 and 10C4. The designations are there, and it is having their carbon content like 0.10 in 5C4, and 0.12 maximum in 7C4, and 0.15 maximum in 10C4. And you can see the applications of these three standards in the industry. Okay, so like in they are used in automobile body parts also, they are used in oil pans also, they are used for cold heading wire also, rivets, and you can see they have numerous applications like steel sheet strips on rod and wires which having good finishing. Okay, so the another designation that you're seeing, that 10C4 and 14C6. So you have these are case hardening steels that are used for making camshafts, cam light duty gears, and gudgeon pins that are used in the automobiles in the engine. Then spindles, and then pawls and ratchets and chain wheels. So you can see that there, as per the standardization designation, the applications are also there. Okay, then the 15C4, the chemical, the standard is there, and you can see that is used for light stress parts. So these are having their applications, which are you can say which are usable in the industry. Then you can see that there are also standards, and you can see that these are general purpose steels used for low stressed components. Okay, then you can see this 13C8 30C8, sorry, 30C8 this steel is having, you can say, tremendous application as shift and brake levers. Okay, and you can see them for sprockets and tie rods and rear hubs and two and three wheeler scooter parts such as sprocket lever hubs for forks. Okay, then you can see that in 35C8 that it is used in machine structures and motorcycle tubes and fish plates. Okay, then the 45C8, so it is used in spindles of machine tools, bigger gears, bolts, lead screws. So you can see the applications are increasing. Okay, and this is how they have segregated the material and their usage. Okay, and based upon the percentage of carbon and manganese, or you can easily understand their usage also. Okay, again, this is the you can say like this is also again a material designated like 15C12. You can see the carbon content is 0.45 to 0.55. So you can see that is a rail steel. Okay, it is made for spike bolts and gear shafts and locking levers. Okay, now there is a standard steel as 50C4. So you can see it is used for keys and cylinders and machine parts that require moderate resistance. Okay, so it is also suitable for large pitch worms and gears. And then you have 60C4, so used for clutch springs, okay, screws and nuts, and machine tools, couplings. And then 65C9, that is used for locomotive carriages and tires. Okay, so the various steels have various applications. Okay, like 65C9 is also used for engine wall springs. Okay, washers, thin stem parts. So the applications are increasing. Okay, then effect of impurities on steel. Okay, then uh, so in this, okay, you can understand the various impurities, the effect of impurities on the steel. So let's go to the quiz for now, because we should solve the quiz also in this lecture. So let's go with the quiz. Now it makes the cast iron. Excuse me. Right. Now the first question is it makes the cast iron hard and brittle. So since too much of dash gives unsound casting, so therefore it should be kept well below 0.1% for most foundry purposes. So what is it is called as sulfur. Okay, it is called as sulfur. Now the second question arises that it makes the cast iron white and hard. So it is often kept below 0.75%. It helps to exert a controlling influence over the harmful effects of sulfur. So what is this? This is it's manganese. The answer is manganese. Okay. Then the third question, it may be present in cast iron up to 4% and it provides formation of free graphites which makes the iron soft and easily machinable. It also produces sound castings free from blowholes because of its high affinity for oxygen. So what material, what element is this? It is called as silicon. Okay, it is called as. Then in engineering materials, it is the purest iron which contains at least 99.5% iron, but may contain up to 99.9% iron. We have discussed this. It is wrought iron. It is wrought iron. A iron. A option is the answer. And it aids fusibility and fluidity in cast iron, but includes brittleness. It is rarely allowed to exceed 1%. So it is phosphorus. The answer is phosphorus. Now, in engineering materials, the alloy cast iron has special properties like increased strength and high wear resistance and corrosion resistance or heat resistance. So, it is true or false? Okay, so answer is true. Okay, the answer is true. Now, in engineering materials, the percentage of carbon in these steels, the percentage of carbon in these steels, they range from 0.5% to 0.15% to 0.25%. So what do we call this? We call this as low carbon or mild steel. Okay, call this as now the engineering materials, the percentage of carbon in these steels contains up to 0.15% carbon. So what do we call this? We call this materials as dead mild steel. We call this as dead mild steel. Now in engineering materials, the carbon content in this steel is 0.3% to 0.6%. Okay, I repeat once again. The carbon content in this steel is 0.3% to 0.6%. So the strength of these materials is high. So what do you call this? We call this as medium carbon steel. What do you call this? Medium carbon steel. So because the carbon content in this steel is 0.3% to 0.6%, and the strength of these materials is really high. So we call this as medium carbon steels. Okay, medium carbon steel. When the carbon content in the steel is 0.3 to 0.6%. Medium carbon steel. So last question, the engineering material, it is the hardest of the plain carbon steels and contains 0.6% to 0.6% to 1.5% carbon. Okay. Now see the increase in the percentage of carbon. So it is the hardest of the plain carbon steels and contains 0.6% to 1.5% carbon. It possesses good tensile strength. So what do we call it? We call it high carbon steel. We call it high carbon steel. As the name says, it is the hardest plain carbon steel. So it is high carbon steel. Okay. It has carbon of 0.6% to 1.5% carbon. That is the hardest of the plain carbon steels. So answer is D. Now we have completed our MCQs and we have also discussed our lecture in detail. So here are the references which you can refer and increase your knowledge in this subject. And if you read good books, then you also increase your knowledge in a better way. Thank you all.